week 11. So let's starting with the first question. Which of the following statement is true or correct? We are asked about the correct statements. So the correct statements are the partitioning divides a given top level design into smaller parts called blocks. So as you know that in partitioning what we do, we create a group of logically connected elements and we group them together. And what we call them? We call them blocks. Blocks or macros. These things we call them. And what we try to do, we try to segregate, we try to break down our complex design into form of blocks. So partitioning means given top level design into small parts called blocks. This is a correct statement actually. And then next statement is budgeting allocates some fraction of clock cycle to different blocks and the top level design for signal crossing block boundaries. Yes, this is also correct statement. Let me tell you. Like suppose I have several flip-flops attached and I want that the timing requirement need to be met. So what I will do, some portion of clock I will make sure that this thing will take like 30% of the clock and this will take 30% of the clock. Other things are taken by the top level of the block. So this is called budgeting of the time period that we have. This is the budgeting of the time period that we are going that we have. So we allocate some portion of time that an individual flip-flop can take place, okay, that it can acquire from that time. So this is called budgeting. And this statement, the second statement is actually correct. The reference are given in the slides also. I will show you from where from you can take the reference also. Next, go to this statement. Top level assembly integrates all the blocks at the top level. So yeah, this statement is also correct. In top level assembly, we integrate all the top level blocks and we do the analysis after removing those flip-flops or blocks. We only do this skeletal analysis of the block. So let me give you the references now. It is discussed in the earlier part of the earlier, I think, first lecture of this week. Let's quickly jump into the references. So just a second. Yeah. See here. Top level assembly, it integrates all the blocks at the top level. We carry out verification at the top level and we emit all the timing paths to and timing paths contained entirely within a block. So these timing paths, it means these flip-flops will be removed and we are going to take consider these paths. Why? Because we are going to remove this flip-flop because its timing requirement was already being considered while we are taking the block constraint value. Okay. Some amount of timing for this block was already given to it. That's why we can omit it. It has been explained in the lectures. You can refer to that. And budgeting means allocating some fraction of clock time to different blocks and the top level design for signal processing. Like I was saying, different block will create their different SDC file. Like B1 block will create this B1.SDC, B2 block will create this B2.SDC. SDC means synopsis design constraint files, contains the timing reports and all. And here, mm, what was that? First one related to partitioning. So partitioning means partitions are called blocks, and partitioning means logical functionality by making the clusters of the logical elements as I mentioned you. We make the blocks and yeah, logical connected elements are called blocks and this and partitioning we do our make our complex design into form of blocks only. So all the three statements are correct. I hope you understood all these three. And the correct statement is all A, B, and C. Let's move on to the next question. The next question is consider the following functions and which of these functions is typically provided by an IO cell in an integrated circuit. Okay, IO cell they are asking about. So perform multiplication of binary numbers. No, why IO cell does not perform any binary operation, any any arithmetic operation. They increase the drive capability. Yes, IO cells do contain some buffers and they increase the drive capability for the outgoing signal so that external load, if there is any, that can be derived by the signal coming from my internal circuit or from the core area of my some signal is coming, that strength can be increased. And then third statement is it protects core cells from electrostatic discharge. Yeah, that is also correct. So my core can be is very sensitive to the electrical current. Like suppose it can happen that some electrostatic discharge, the kind of electrical shock that we can get sometimes when we touch a metal suddenly after walking on walking on a woolen after like when we rub something on the woolen thing and we touch the metal, you can understand this electrical discharge, right? So this the same thing, it can occur with our die area to the internal circuit also. So uh, the main function here of the IO cell is to protect them from this electrical surge that can actually affect my circuitry. So they kind of provide us the robustness. Robustness means they provide uh, a solid defense mechanism for this kind of electrostatic surges, and then our circuit is protected. So now let me give you the reference. So these are related to the IO cells, and these were discussed in earlier part of week itself, I think in the first lecture. So let's go into that. Yeah, here are the IO cells basics. As you can see, so IO cells give us the protection against the electrostatic discharge, right? And they improve the drive capability. Drive capability, yeah. From here, the drive capability will be increased, and this signal will be given to the external load if there is present. Okay. So I hope you understood this solution. Let's go. Let's go to the third one. Yeah, only B and C is correct for the question number two. Okay. Let's go to the third one. The special circuit element that supplies power to the chip is called as power pads, filter cells, integrated call as clock gator, ICG, or spare cells. So yes, power pads are the circuit element that supplies power to the chip, right? See here. Where is the reference? Are you saying? Yeah, this is the M pad. M pad that is called metallic pad. Metallic pads are also called as the power pads. So they are the metal pads. So power pads are connected to the bond wire to the metal pin, and they actually provide this interface to the external signals and the die area chip, the internal circuitry. That was written here, right? It supplies power to the chip. Yes, it is the power pads or metal pads. Yeah, this is the answer for this question. Let's move on to the next one. Consider the following statement about chip planning. The placement of macros is typically undertaken during floor planning. Typical placement of macros, yes, this is correct. Macro placement happens during floor planning, and the placement of standard cells, it is done by a placer tool, and it happens at the placement stage, right? Happens before floor planning. No, this is not wrong. This is sorry, this is incorrect, and this is the correct one. Fly lines can be used to guide macro placement during floor planning. Yeah, this is also correct. Okay, I will come back to this question. Okay, so the fourth question again, let's see this. So we have to see the statement which is correct. So the placement of macros is typically undertaken during floor planning. So yes, this is correct. Macros are placed during floor planning. Macros are the larger design blocks, if you remember. It has been discussed in the video lectures by this week also. Like the macros, this is your die area. So what we do during floor planning, we place the bigger objects. The bigger objects are called blocks or macros. These are the IPs, the intellectual property, which can be hard IP or soft IP. Like a macro can be hard or soft, which means that it has a fixed dimension or we can change the dimension also. It depends on it. But macros placement is done during floor planning is a correct statement. And then after floor planning, when the times comes to place the standard cells, so that thing is called placement. Okay, that is done after floor planning. Okay, when we place the bigger objects macros, then we go to the smaller objects, that is the standard cells. So that we do after floor planning, not before floor floor planning. Therefore, B option is not correct. And then the fly lines are used to guide macro placement during floor planning. Yeah, that is correct. So what fly lines do is that how closely the macros are interconnected with each other and how many IO pins are connected to the macro. These information are given by the fly lines as it is discussed in the video lectures. Let's go to the references from which you can solve this question. I will show you the references also. Mhm. Yes, this was the fly lines. These are the fly lines. Okay, these are the fly lines. It can actually help us to guide in the floor planning, and it is tells us how the macros are connected and how the IO pads are connected to the macro, how many IO pads are connected, and how it is interacting with the external world. And then the question was related to floor planning and all. So, so this is one typical design flow that we actually follow in physical design flow. First, we do the partitioning in which we make the blocks, logically connected blocks. Then we do the floor planning in which we place the blocks or macros in our die area. Then we place the power line, and we do the placement. Placement means placement of the standard cells. It is done by the placer tool because there are millions of standard cells. It is done by the placer tool. So it cannot be done manually because the number of standard cells are really huge. And then we do clock tree synthesis, like how the clock signal is going to be given to all the standard cells or the logical gates, I mean the flip-flops, logical gates itself. So how the clock signal is given to them, and then we do the routing with the routing algorithm that we have, and the minimum amount of wire that we should give with the optimal connection that should avoid the congestion and cross talking between the signals. These things are taken care of. So I hope this question is clear to you now. Let's go to the question again. Yes, the fourth question. So the first statement that placement of macros is typically undertaken during floor planning. This is correct. And fly lines are used to guide macro placement during floor planning. This is correct. And as I explained you, the placement of standard cell is done after floor planning. After placing the macro, then we deal with the standard cells. Okay. So statement A and C are correct for question number 4. Moving on to question number 5, consider the following statement about mesh grid topology in power planning. So let's see the correct statement it's being asked here. Hmm. So if you see here, rails and straps are organized as a uniformly spaced array in a mesh grid topology. So yes, this is a correct statement. It has been shown there in the slides also. Like we form the mesh grid topology in such a way that there are these two lines are non-touching to each other, but they are perpendicular to each other, and they all lie parallel to some plane, but they do not touch each other. They connect each other through via. Via is the interconnection between those lines. It is a vertical connection, and that's how we interact with the standard cells or the macros. And this kind of placement is done. Okay, this one is VDD line, next will be ground line, then VDD line, then ground line. That kind of mesh grid topology is being formed. So this is actually correct statement. The resistance from power pad to any point in the grid is typically low because there are many parallel paths in the mesh grid topology. Yes, mesh grid topology, one of the advantages is that we are able to give a low resistance path and provide robustness to the circuit. Okay, so these things are, this is a correct actually. Yeah, this is to give the low resistance path so that our power loss can be minimum and we can optimally give our signal to the die area to the our main circuit. So this is correct. And robustness of circuit of the mesh grid topology is low. No, it should be high. Robustness of mesh grid topology is high. It is given as low. So this is correct. Incorrect. What happen is that if any of the circuit fail, so we have other routes also, other paths also to reach to that given logical cell or whatever the whatever the element that requires power, we can reach there even if my wire breaks, because I can reroute my signal so that I can reach to that particular wire. Because of this because of this VDD ground mesh grid topology. So C is not the correct option. A and B are correct. Okay. So in the sixth question, it is asking, why do we need to carry out legalization after global placement during standard cell placement? Yeah. In the global placement, there are millions of logic gates or the standard cells that need to be placed, and the placer tool will deal with the placements of the standard cells. So at first, what will happen is that, now suppose this is my mesh grid topology, VDD line and ground line, all other things. Now in the earlier, what at the first step, what will happen is that some standard cells will be at the illegal locations, between it will be between the power lines, not between VDD and ground lines. And it can happen that some standard cells are overlapping to each other. So these are some irregularities that we need to remove. And to remove them, the process is called legalization. Okay. So the legalization is to removing the overlap of, among the standard cells. So this is the most suitable option here. Another option will be like placing the standard cell in the legal location. Legal location is in between the power lines and they should not overlap. So this is what we need to take care of. So this option is correct. In the seventh one, which of the following statement is about the decap cell? Decap means the decoupling capacitor. So the role of decoupling capacitor, I will tell you, like suppose I have a logical circuit here, and this is my circuit, standard cell, whatever. And there is an IO port that is driving power to it. So the buffer, this is driving power to it. And suppose I have a decap capacitor also. Now what will happen is that if I have a decap capacitor already pre-charged, if it is pre-charged, then along with this input, IU input, this decap will also be charging, and due to that, my my charging of this device means uh, the rate in which I can able to give input to this standard cell, that rate will increase, and I am able to do my computations or the processing faster. So decap capacitor is a capacitor that is inserted between the power and ground lines. That is correct, and it helps in mitigation of problem of IR drop hotspots. Yes, it can it can give you quickly the charging of the capacitor, and the IR drop can be reduced. Why? Because from the source itself, if I am giving my current or the user supply voltage or current. So it will happen that in the path IR drop can happen if the length of wire is increasing. So in that case, we can quickly charge through the pre-charge capacitor also, the decoupling capacitor. So in this way, we are able to drop the IR drops hotspots. So option A and B are correct. In the next one, the extra cells that we put in the integrated circuit is in anticipation of later use are known as spare cells. Yeah, it is just a one word answer, spare cell. Spare cells are placed when we are done with all our placements thing of the standard cells, and then we would give some extra cells, as spare cells, so that it might happen at the later stage of the design, we might require connecting them with our design, integrating them, but we have to make sure that they are not connected during the placement. Like a placer tool and the routing tool, they should not connect wire to them. We have to specify that, okay, these are my spare cells, and these things are discussed in the video lecture also. So spare cells is the correct answer for this question number 8. Ninth question. So these are also a one word kind of answer only. The ninth question again. So you have to select the correct statement. So let's see the commands, what they do. The command read underscore SDC. It reads the SDC file, the design constraint file, SDC, synopsis design constraint file. So this is a correct statement. This one is correct. And the B option, the place underscore pins. It can be used to synthesize a design. So place underscore pins, what it will do, it will place the pins, the IO pins that we say near to the macros or near to the macros or to the elements which require power, which are related to the inputs, which require the power of the input lines. So that place pins are used to synthesize the design. No, it is used to just place the pins. It is not correct. The command write underscore def can be used to read the DEF file. What is DEF? Design exchange format. Design exchange format files. So the command write dot underscore DEF, it is used to not read but write. Write the DEF file. Write the DEF file or export. We export the DEF file and we can write on that. So this is also not the correct one. Correct is only A option. Next, what is the purpose of report underscore TNS? TNS means total negative slack. Negative slacks are the paths which are violating the timing analysis. Timing violations are there. That's why the slack is negative. I mean, there will be setup violation or hold violation due to that. The slack will be negative, and my purpose of this report underscore to TNS will be to report the negative slack paths, and we are going to optimize it using the tools that are available to us during the physical demos. So yeah, that's all about the week 11 solution. Feel free to ask any doubt. I'll be happy to answer.